Hi everyone, my name is Kitmina and today I'm going to do an analysis on two protocols, namely UDP or User Datagram Protocol as well as the IP or Internet Protocol. So when first looking at UDP, UDP is a transport layer protocol in the OSI model and it is stacked on top of a network layer and it's a counterpart of TCP, which is the Transmission Control Protocol. So UDP is connectionless, meaning no connection set up at the sender or sender and the destination, sender or destination, and there are no tracking or acknowledgement numbers, so that there's no way of tracking it and acknowledging. Packets won't be sent back, and there are no sequence numbers and flags available on the in the packet. This is commonly used for broadcasting. So the best example I can give you is VoIP, which is a voice over IP technology, which has been used by operated by internet telco companies. So the basic software which are using UDP is WhatsApp and Viber, Skype, etc. So it is actually considered as its delivery rather. It's considered as a best effort rather than uh, reliable connectivity because it doesn't send rather than TCP. It doesn't send any. It doesn't establish connection between the sender and receiver before having communication with them with each other. So and in ARPANET terms before internet, that is UDP was UDP had the RFC or the request flow command of a number as 768. So it doesn't send, it doesn't provide any segmentation. Instead, it uses single packet uh, transfer uh, with error detection. However, the packets cannot be detected, the error cannot be prevented or error cannot be corrected in packet. So whenever there's an error, you can actually check the error from because of the checksum which is available on the UDP packet. But however, you cannot correct them. So basically, what the what the communication does is like when there's a corrupted packet in the communication, it will either uh, dump it or it's gonna keep on sending it even if it is corrupted. So this protocol works in conjunction with other high-level protocols such as SNMP, which is the Simple Network Management Protocol, and TFTP, so which is a Trivial File Transfer Protocol, as well as the DNS service. Unlike the TCP, UDP, when sending a request, when the receiver sends a request to get packets from the sender will keep on sending packets rather than waiting for a acknowledgement packet back from the receiver. It's going to keep on send responses without getting the acknowledgement or confirmation from the receiver. So that is basically the difference between UDP and uh, TCP. So the key points to remember in UDP is that it has like this packet size, so which is 8 bytes, rather than in TCP it's a 20 byte packet. So the other one is that there are no congestion control. So basically, what it means is like when the network is busy and rather than like stopping and making the network waiting until the network becomes available, what UDP does is it actually try to squeeze in the packets inside that congestion. So main issue that you should remember is that the package, sometimes the packet which is being sent from sender to receiver, sometimes can be out of order. Meaning, as an example, if I give you, if I send a packet which is A and B, the receiver might receive it as B and A. So that you should keep in mind. Because of these reasons, UDP is not considered as very reliable connectivity, because it's not having uninterrupted connectivity. It cannot guarantee that, and it cannot guarantee that you will be receiving the packets which will be sent by the sender. And because of these reasons, it's not considered as very reliable. So let's move on to Wireshark to analyze UDP and IP. So on this, I'm using Wi-Fi because I'm connected to the Wi-Fi network. So when you click on that, you can actually see there are a lot of traffic going, in and out of networks in my network. So to check the UDP, I'm gonna just do a quick filter, which is UDP dot port, then equal. Then actually I'm gonna check UDP in DNS. So I'm gonna type 53, which is the protocol the port number of the DNS. So now press enter. So now it's been so in this one you can actually see the bit of traffic. So in this one, the source address is this is my laptop IP address, and destination is basically the DNS, which is my router. So when you actually expand this, you can actually see the frame number is 526, and then there are byte. How many bytes are there? Which is 712, and how many bytes have been captured. Uh, and basically, since it's a UDP, you can actually see the checksum value, but since it's somewhat inaccurate and all that, you can actually see it's unverified. And the other main thing you will realize is that it doesn't have any sequence numbers and acknowledgement number, so there's nothing there. So on top of that, you can actually see the interface name, and if you go here, you can actually see the protocol version and how many flags are there. Since the flags are not there, it's going to show you as 0 into 000, and so you can actually see the source and the destination of this packet. Thank you.